The next thing to think about is the regiochemistry of the reaction. The word regiochemistry refers to the location of the reaction, the region where the reaction takes place. The most important take-home message is that the most stable alkene forms in an E1 mechanism. And the most stable alkene is the one that's the most substituted. The most substituted means the one that has the lowest number of hydrogen atoms around it. So as an example, the bromine is the leaving group, the electronegative atom next to the alpha carbon. Remember, in an elimination reaction, we remove the proton on the beta carbon, which is the carbon next to the alpha carbon. In this case, we have 3 different protons that are possible. And in fact, the carbons that I have labeled B1 are identical to each other. So there are really 2 different types of protons that we can remove. We do the elimination reaction, and we can imagine that water is the solvent. There are 2 possible products. First, if we remove the proton from the B1 carbon. Second, if we remove a proton from the second carbon. The alkene, A, is trisubstituted, whereas B is only disubstituted. The more substituted the alkene, the more stable. So A would become the major product from this reaction. The next characteristic to think about for an E1 reaction is the stereochemistry, where stereochemistry means the arrangement of atoms in space. Again, in this reaction, the most stable product is the major one. For example, if I take this alkyl bromide, the alpha carbon is the one next to the bromide leaving group, 2 types of beta carbons. If we eliminate, imagine again in the presence of water as the solvent, we can get the double bond between B1 and alpha. There are 2 types of alkenes that are possible, and 2 arrangements of the double bond between alpha and B2. There's the one in which the double bond forms and the zigzag remains intact. This is the E isomer. Remember to go and review E and Z alkenes if you haven't done so already. The other possibility is the Z isomer. So we have monosubstituted versus disubstituted versus disubstituted. Right away we can say the one on the left is minor because it is only monosubstituted. Now we have to compare between the 2 disubstituted products. Again, we come back to the idea that the more stable product is the major one. So for the alkene that has the 2 larger methyl groups close to each other, that creates a steric interaction. Remember that steric interactions tend to raise the energy of the molecule because they have overlapping electron clouds that cause electron repulsion. So the compound on the right, the Z isomer, is minor because of a steric interaction between its methyl groups. That leaves the E alkene as the major product. In summary, the major characteristics to think about for an E1 reaction are the degree of substitution on the alpha carbon. A good leaving group is required. Weaker bases favor the E1 mechanism, and ideally the solvent will be polar and protic. In terms of regiochemistry, the most stable or most substituted product is the major one. In terms of stereochemistry, again, the most stable product is the major one.